Hello. So we'll be solving this question, climbing stairs. We are given a condition where we need to climb the stairs and it takes n steps to reach to the top. Now we can climb the stairs in two different ways. One is we can either climb it one step at a time or we can climb it two step at a time. We need to find how many distinct ways can we climb to the top. Here we are given some examples and these are the constraints. So we can solve this question in a couple of ways. The first one would be finding out all the conditions and then checking it. But let's say that we do that. Let's see if we were to do that in n is equal to 3 condition. Now we'll start from the base case. From the base case, we have two options that we can take. One is if we climb by one step, and the second one is if we climb by two steps. Now if we climb by one step, now again we can take two decisions. If we climb by one step, it would make take us to the second step, and if we climb by two steps, it would take us to the third step. Again, on the second step, we can have two conditions. We can go to the first the by one or by two. This is out of bounds for us, so this will not be considered. Now, again on the second step, we can take two conditions. We can climb by one or we can climb by two. Again on three, we'll have two conditions, which would be we can climb on the third condition. We have already reached our end goal, which is on the third step, so nothing will be done in this manner in this case. But this is out of bound, so we came out with one route, the second and the third one. So there are three steps in with this. If we are following this, the way in which we get to the solutions is we got we'll get the time complexity for this solution would be 2 to the power of the height of the decision tree that we got. So in this case, it would be 2 to the power h, where h is equal to 1 to 3. Yeah. So this is not the optimum solution, but we can see that let's say that if we know that on the second, if we have already calculated for the value of 2, then we need not calculate it here again, because the values which we are getting here is 2, then 3, then 4, which is the same as the subtree that we got here is 2, then 3, then 4, then here also it is 2, 3 and 4. So what will happen is, instead of going calculating each and every decision, we can go to depth first search and save the output. In this manner, we'll be able to get down the time complexity to O of n, where we need to only run go to depth first search on this particular subtree, and then we'll save all the values. Let's do this from the 0th case to the third one. If I'm on the third step, how many ways are there in order to reach the third step? It would be 1. We are already at the answer. From the second step, how many ways are there to reach the third step? It would be again 1. And this would be true for all the cases that we have. Like if we have 5 cases, 5 steps, 6 steps, then it would be the case for all of them, like it is 0, 1, something, something, then 10, 11. So what will happen in this? What are the various ways to reach the 11th step? It would be 1. From the 11th step to the 11th step, it would be 1. And from the 10th step to the 11th step, it would again be 1. So this is true for all the subcases. Now, from the first step, what are the various ways in which we can reach the third step? It would be 2. We can go one by one, or it would be directly 2. We can jump 2 steps, so it would be 2. Or we can say that it is the sum of the values that came just before it. Now, to reach nth step, we can have some, we can see how many steps did it take to reach n minus 1 step and n minus 2 step. Is that what we can do? So what we are coming up with is, this is a factorial series. Now from the base case, how many steps can we take? We can take these two, which is 3. So in this manner, we are able to reach to the solution. Now we can again take two solutions for this. One is, we can have a hash map where we have all the values, or we can take an array and we can store the values at the particular index and we can get to our solution. Or instead of doing that, we just need two variables which are being updated again and again, and then we come up to the base solution. Let's see what I'm trying to say in the by coding. What we'll do is, int 1, int 1 is equal to 1, int 2 is equal to 1, while n is not equal to 0, while n is not equal to 0, we'll take a temporary integer, int temp, which would be equal to um, 0. We'll take temp and we'll update it by 1. We'll take 1, 1 and 2, and third value. One is being updated with 1 plus 2. 2 is being updated by temp, and so we'll take 1 plus 2, and temp would be 1 again, and we'll just return 1. Let's test it against the open test cases. Time limit exceeded. Okay, maybe this is not the right solution. We'll take for int I is equal to, we are starting at 0. Okay, so I is less than, we'll go to n minus 1, I plus plus, temp is 1, 1 is 1 plus 2, and 2 will be replaced with 1. Let's run this case. This works. Basically, we are going till n minus 1 because the n minus 2 and n minus 1 we need. Let's submit and see. Yeah, this works. Thank you.